Geometry students, in this lesson we are going to be working on disproving conjectures with counterexamples. Does this look familiar to you? Because we've already talked about counterexamples before in previous lessons. So this should seem like something that is a piece of cake. Let's get started. First of all, let's define what a counterexample is. It's an example that proves a conjecture or statement false. Here's the thing. With a conjecture, or even like any kind of hypothesis statement. So if you have any kind of conditional statement, you can, to prove that something is certain for sure, you actually have to prove that every single example of that thing is true. We use inductive reasoning as a way around that. Inductive reasoning says that if you can prove that enough examples, so several examples of something are true, and it seems like it's intuitively true after several examples, then you can assume that the thing is true. And that's after test after test after test after test. When I say several, I mean several, okay? To prove something beyond a doubt, though, you have to prove that every example of that thing is true. However, to prove something is incorrect, you just need one counterexample. One example that proves a statement false is enough to say this statement is forever false, bye-bye, all right? Now, let's take a look at an example of this. What about this statement? If two lines are both intersected by a transversal, then they are parallel. Is it true that we could have two lines that are parallel intersected by a transversal? Yes, and if we do, all of those postulates and theorems related to, for example, the same side interior or the alternate interior, alternate exterior, those postulates and theorems related to parallel lines and a transversal are all applicable. But remember, in investigation 1, we found that not all transversals cross parallel lines. So here is my counterexample. The only thing I could have done to make this a little geometrically better was put line names A, B, C on these lines. Okay, but this is a counterexample to the statement because this is a transversal and these lines aren't parallel. So that means that it is not true that if two lines are both intersected by a transversal, they are parallel. Sometimes they intersect. These two would intersect somewhere over here. Okay, so I have a counterexample. And that's what we're going to be doing. Now, here's the thing. We're going to be doing some geometric counterexamples like this, where you can show some geometric drawing to prove the counterexample false. We're going to be doing some algebraic counterexamples, and we're just going to be doing some real-life, on-the-streets counterexamples, okay? So let's get started with the lesson practice right away. We need to use this conjecture for A and B. If a line is perpendicular to line B and to line C, then lines B and C are perpendicular. Now, you know by now, if you run into a problem like this, you've got to draw a picture of what's going on before you can fully understand it. Maybe you can keep all this straight in your head, but if you can do that, you are a better person than I am. So instead, draw a picture. And actually, in drawing a picture here, you're going to find that you're going to draw the counterexample. All right, but here, it starts off with the question, what is the hypothesis of the conjecture? Remember, hypothesis and conclusion do not never include the words if or then. So this one would be line A is perpendicular to line B and to line C. That's the hypothesis. The conclusion, that I should label that hypothesis. And then the conclusion here would be let's see. Lines B and C are perpendicular. Lines B and C are perpendicular, and that's the conclusion. Okay? Now, again, we're not stating what the truth value is yet. We're just identifying what the hypothesis and conclusion are. All right, letter B, find a counterexample to conjecture. Well, I've got this one prepared. Okay, here's my counterexample. I just drew what was being described, and it's a counterexample just by drawing it. Okay, so here I drew line A perpendicular to line B and C. I put in my perpendicular markers. Then lines B and C are perpendicular. What? That can't possibly be true because lines B and C are obviously parallel. In fact, we have theorems and postulates to prove that lines B and C are parallel if they're perpendicular to the same line. That was a theorem, I think, from lesson 5. So this is not true. This is abhorrently not true. And here is this is part B, okay? This is my counterexample. It's a drawing when we're dealing with geometric examples. All right, so let's take a look now at letter C. I have another conjecture I'm going to look at. In this one, we're going to look at a algebraic conjecture. And dollars to donuts, because it's this lesson on counterexamples, it's probably not going to be true. But let's take a look. So letter C. What is the hypothesis of the conjecture up above? If x squared equals 9, well, that's the hypothesis. X squared equals 9. Okay? And then what's the conclusion? So I'm just going to label that, by the way. That's the hypothesis. And then my conclusion is whatever comes after that. X equals 3. That's my conclusion. All right? Letter D. Find a counterexample to the conjecture. What else could x equal that gives x squared equal 9? This one you do have to do at least a little thinking. X could also equal negative 3. Because remember, to solve x squared equals 9, we have to take the square root of both sides. What happens when you take the square root of 9? You get 3, but the little known sister of that response is you also get x equals negative 3. It's x equals 3 or x equals negative 3. In this case, x could equal negative 3. That's the counterexample. If x equals negative 3, x squared equals 9. All right. So letter E. This one is really, really, I don't know. I'm going to have to do some calculations. I think I'm just going to do my calculations in a Google browser here. The masses of two sedimentary rocks are 327 grams and 568 grams, respectively. Their volumes are 275 centimeters cubed and 501 centimeters cubed, respectively. Explain how this data disproves the conjecture below. If a rock is sedimentary, then its mass is proportional to its volume. Here's what's confusing about this, okay? You kind of have to get inside the conjecture maker's head a little bit. What they're saying is that all sedimentary rocks have the same proportion of mass to volume. That's what they're saying. Now, do they say that in the conjecture? It's kind of hard to read that in that conditional statement. As I read it, I don't know if I necessarily read that. I would say if a rock is sedimentary, I don't know how I would say it. If a rock is sedimentary, its mass is proportional to its volume. Hey, all rocks technically have masses proportional to their volumes, but in this case, we have two sedimentary rocks. They could be different rocks, and they would have different density. Like proportion of mass to volume is density. We learned about that in science class. Different kinds of sedimentary rocks are going to have different densities. Like that should be obvious. But anyway, to prove this wrong, okay, we need to explain how the data disproves the conjecture. We're not just providing a counterexample. We're proving that the data itself here is a counterexample. And here's how we're going to do that. We're just going to find the densities of these rocks. Mass over volume, mass over volume, mass over volume. So first it's going to be 327 over 275 equals. All right, here's where I'm going to have to do some math. 327 over 275. I get a density of 1.19. So 1.19 grams per centimeter cubed. Okay? Now, let's see if the second rock has the same density. This is going to be 275 over 5. Let's see. Hold on. Nope. Mass over volume. Mass over volume. That's what I was saying it before. 568 grams over 501 centimeters cubed. If this is the same, my data proves the conjecture. If this is different, my data disproves the conjecture, and not all sedimentary rocks have the same density. All right, let's see if we could do this. 568 over 501. 1.13. Does that match? 1.13 grams per centimeter cubed? It does not. All right. Because these values are different, the proportions of mass to volume are different for different sedimentary rocks, and therefore I can't just say if a rock is sedimentary it has the same mass proportional to its volume. All right, that's it. That's what you're doing. You're finding counterexamples for questions. I will do my best to make sure that none of the questions sound as difficult as letter E or as difficult to ascertain. If it is one like this, I'll give you a little bit of a note that explains what's being stated. All right, you're ready to do lesson 14, numbers 1 through 30.